Hello, this is Jonathan Kamlegea once again, and today I'm talking about the nuclear processes. What do you understand by the term nuclear processes? These are basically reactions which take place within the nuclear processes or nuclear reactions. What we need to understand, what does it mean? As you can see on your screen, I've talked about four types of nuclear reactions. We have the reductive decay, we have the nuclear fusion, and also the nuclear transmission. Basically, as you can see, these reactions, they take place by releasing a certain component or a certain emission which is being given out. But let's first understand what's a nucleus. For any nuclear reaction to take place, this reaction takes place within the nucleus of an atom. If I try to talk about the nucleus of an atom, for any for any nuclear reaction to take place, it must take place within the nucleus of an atom. For us, we know that our atom is made up of three particles. If this is my atom, it has what we call the nucleus. Also, it has what we call the shells. In these shells there, we find their electrons, whereas in the nucleus, we are going to find there two particles, the protons plus the neutrons. Therefore, for any reaction to take place, we are going to play around between the protons plus also the neutrons. First, we need to understand the stability and also the unstable type of nucleus. That's what we are going to focus on in our discussion here. Something is said to be stable in physics if it has the same number of protons as well as the same number of neutrons. If an atom it has got these protons are the same as these neutrons, therefore we shall conclude by saying that that nucleus is stable, and therefore nothing much is going to be taken in such type of reaction, because our reaction is stable and reaction won't take place. The reason why we are having these nuclear reactions, simply because most of our components we are dealing with, they are unstable and they want to attain stability. Therefore, for us, something it will be said to be unstable if the number of protons, these protons within the system, they're not equal to the number of neutrons. If protons don't equal to neutrons, therefore we shall conclude by saying that our nuclei is said to be unstable. But something to be unstable, it's not something good. For us, we need to get ways to ensure that our substance is said to be stable. If something is said to be unstable, there's something must be done to ensure that our reaction is stable. And this is what we need to focus on. We need to see how we can release of some protons or some neutrons to ensure that the number of these two are balancing out. Take an example. If an atom, it has got more of protons than the neutrons, we can either release some protons to attain stability, we can either gain some neutrons to attain stability. That's what we are going to look at to see how such reaction can attain stability. But since we are looking at physics, we need to look at some radioactivity reactions, because we know that these nuclear substances, for them, they keep on emitting or give out some particles in order to attain stability, and such reaction or such process will be called radioactivity. That's why we say radioactivity is a spontaneous disintegration, meaning that this reaction takes place on its own. The spontaneous disintegration or the spontaneous breakdown of unstable nuclei. We are getting our unstable nuclei, we are trying to break them down in order to attain stable nuclei. That's what we are looking at in this type of reactions. Under the radioactivity reactions or process, we are getting our unstable nuclide. As we said, we need to ensure that these particles, they lose out some electrons, some neutrons or some protons in order to attain stability. This can only be achieved under a radioactivity reaction, which is a spontaneous reaction. We break down the unstable one in order to attain the stable one. Now, when these reactions or under this process, we shall do what we call emission or release of some particles of radiance. Some of these particles which we are going to talk about here, we are going to talk about the alpha particle, the beta particle, and the gamma rays. These ones, they aid our reactions to take place they allow our unstable nuclide to attain stability because they will lose some of these particles. They will lose some of these particles as we are going to talk about the reaction. What you need to understand about the radioactivity reaction, these reactions, they are spontaneous, they occur naturally, it's a natural process. And also these radioactivity reactions, they are random process. These radioactive reactions, they are not affected by temperature. And also the elements which I'm going to talk about, we shall call them a name known as the radioactive elements. As you can see, these elements or these particles which are emitted, I've talked about them. They're basically three: the alpha particle, the beta particle, as well as the gamma rays. Let's look at each and every these particles in detail. If you look at how do they work, if you look at the alpha particle, this alpha particle, they are basically called the helium particles. Helium particles. If you remember your chemistry, helium particle 4, 2. The number up is called the atomic mass. The number down is called the atomic number. Now these particles, they'll keep on releasing these particles. The atomic number, the atomic mass is 4 and the atomic number is 2. If I have my substance, if I have my unstable nuclei, let me say I have radium. My radium, let me say my radium, it is Ra. And this Ra, it is 226, 226 and 88. This particle undergoes a decay or a radioactive decay, and then it ends up releasing a given particle, rhenium. This rhenium, let me say it is releasing an alpha particle, which is 4, 2. That implies that if I try to balance out this reaction, if this is A and this is B, therefore to get my A, I will simply come and I say A plus 2 is equals to 88. If I get my A to be the same as 88 minus 2, giving me 90. 88, let me say 88 minus 2, it must give me 86. That could be my A. To get my B, I'll simply do the same procedure here. It will be B plus 4 is equals to 2, 2, 6. B is equals to 2, 2, 6 minus 4. Therefore, my B in that case is going to turn out to be 2, 2, 2. Therefore, my my radium, it will turn out to be, in a given reaction, to turn out to be Ra, which is 226. This is 88, giving us radium, which is going to be now this is 2, 2, 2. Whereas this one's going to be 86. Plus our particle which is being emitted, our alpha particle, which is helium, He 4, 2. Basically, that's what happens in our reaction. You are looking at that. This compound here is unstable, is trying to attain stability by releasing some of its particles to form a new particle. Now, the reason why we say these nuclear reactions are somewhat dangerous, because for them to attain stability, it's a little bit hard. These reactions keeps on disintegrating all the time. They keep on changing. If it releases a particle, it forms another unstable nuclide. If it releases other particles, it forms another unstable nuclide. The reaction keeps on. It's a continuous reaction. We can't say that now we have attained stability, the reaction has stopped. That's why nuclear energy, it's one of the best energy we can achieve. You can get that uranium component, it can keep on reacting throughout its life. It will not stop reacting. It will be decaying all the time. If it decays, it forms a component. The component which is formed, it is unstable. It decays again. It keeps on releasing energy continuously. Basically, that's what we talk about the alpha particle. I can put another example. Here, let me use uranium now. If I have my uranium, which is 2, 3, 8, and 92. This compound can undergo decay by emission of our alpha particle to give us another unstable compound, which is thorium. Here, this will be another alpha particle being given out 4 and 2. You have to remember that. If you try to balance, this will be 238 minus 4 to give us 234. 234. Now 92 minus 2 to give us a 90. You are seeing another component is being formed by that reaction. It depends on what particle is being emitted in that case of that reaction. If we move further, we can talk about some properties of alpha particle. These alpha particles, they are ever positively charged. These alpha particles can be slightly diffracted by electric and magnetic fields. Also, they have a greater ionizing power. These particles, they have very low penetrating power in that they can be stopped by a plain sheet of paper. These particles are used in photographic films to darken the room. These particles, they have the lowest kinetic energy. Therefore, because of their heavy masses, they are very heavy. Therefore, their kinetic energy or their energy is going to be a little bit lower. That's it. That's what you need to know about the alpha particles. There are so many other properties. You can do more research. We have talked about the decay. You have seen how the decay takes place. The decay is continuous, whereby we get our alpha particle, whereby if the nucleus is unstable, it tries to decay to release some particles to ensure that it achieves more stable component or more stable nuclide or an element. And that process is more continuous. That emission allows it to lose some of the protons and some of its electrons within the system, which enables us to ensure that we have the stability. If we go to the beta particle, for the beta particles, for them, these particles, they are basically allows us to release what you call the electrons. For them, they keep on releasing a particle which is in electron format, which is E0 negative 1. That's the particle which is being emitted by the beta particles. For them, they are basically negatively charged and they give off what you call electrons. Remember, if you try to relate an atom, the number of protons must be the same as number of electrons. Here, we are releasing off electrons, which implies that we are trying to attain the stability of a given component. Take an example. If I have a compound, let me say I have carbon. If I have my carbon, in this case, carbon is 1416. This carbon decays by emission of a beta particle. If it emits a beta particle, it gives me nitrogen plus a beta particle which is E0 negative 1, meaning that we have lost a beta particle. Therefore, 0 and 14 are going to maintain the 14 up here. This negative 1 to add up with the 6 to give us a 7. That implies that I will have my new substance. This substance here to be unstable, but I've gained another substance which is more stable by giving off our electron or our beta particle. What you need to understand that the beta particle is the same as code as the electron, or 0 negative 1. You need to remember that. You should not get confused. The helium we said, we have said the alpha is helium. The beta is an electron, which is 0 negative 1. That's what happens. I can put another example here. If I have my sodium, the sodium undergoes decay, and sodium is 2211. It undergoes decay by emission of our beta particle to give us magnesium plus our beta particle. The beta particle is our electron, 0 negative 1. If this is X and this is Y, let me try to get X in this case. My X plus 0 is equals to 22. Therefore, X is equals to 22. Yeah, here it will be the same as 22, whereas my Y to be the same as Y plus negative 1 is equals to 11. Therefore, Y is equals to 11 plus 1, giving us 12. This will be 12. That implies that our final equation in that case to be taken as sodium 2211, giving us magnesium in that case, which is 22 and then 12. plus our electron particle which is being emitted. As you can see here, this sodium here, it may be unstable. When it gives off its electron or the beta particle, it's going to attain more stable component, which is magnesium. Basically, that's what happens when you're dealing with that. The properties of beta particles, the beta particles, for them, they are ever negatively charged. For them, they are lighter than the alpha particle. And for them, they are deflected by both magnetic and also electric fields. They have got a greater penetrating power compared to our alpha particles. They have less ionizing power, and also they can be used in those formats. We have a number of properties which you can read about and find out. Now, our last particle, which we can talk about here, these are still beta particles. We have seen them. We have seen the decay process, whereby this process take place by releasing of our electron or negative electrons. We have seen that. This takes us to what we call gamma rays. What are gamma rays? Basically, these gamma rays are, for them, they are rays which take place, these are reactions which take place by release of the gamma particles. What do you understand? What do you understand by these gamma rays? What you need to know that for them, they are diffracted by both radiations. The gamma rays, for them, they are emitted from the nucleus of an atom. Unlike the beta and the alpha particles, the gamma rays, for them, they are neither. They don't have either mass. Gamma rays have neither masses or electric charges. For them, they are chargeless and they are massless. What you need to know about them: they have no charge. They are not diffracted by either magnetic field or electric field. They have the greatest penetrating power. They can go through any system. They can only be stopped by effectively a thicker shield. For them, we have talked about the penetrating power is very high, about what we call the gamma rays. Basically, that's what we call about the nuclear processes. In nuclear processes, we need to remember about the three factors in a system. We have to remember about the gamma, the beta, and also the alpha particles. We have seen that our alpha particles, they are going to emit what we call the helium particle, whereas the beta particles, they're going to release what we call the electrons, the negatively charged, whereas the gamma rays, for them, they won't release anything. They don't have charge, or they don't have mass. They are light. They can't release anything. If a particle gives off a gamma ray, it stays the same. Nothing has been changed. It can't release any particle on its own. Basically, that's what I had for today. But before we go, these are some properties. We have seen them, properties of that. Gamma rays, we can talk of the penetrating power of different particles. As we say that the alpha particles have the least penetrating power, whereas the beta particles have a greater penetrating power compared to alpha particle, and the gamma rays have the greatest penetrating power compared to the rest of the particles which may be emitted in the nuclear reactions or nuclear processes. What the last thing which we need to understand here is about the background radiation. These background radiations, these are basically radiations which come from both natural and artificial sources. We are exposed to these radiations in everyday life. Things we use, they give off these radiations. The soil we walk on, the water we bathe, the food we eat, all these processes, they give off these radiations. Some of these radiations are harmful and others are not so harmful. If you look at the artificial sources of background radiations, we shall talk about the nuclear power stations. We shall talk about the nuclear weapons. We shall talk about the medical sources, and so on and so forth. But most of these ones, they are useful in our daily lives, as we shall see how they work out, how they assist us in life.